Asmegum and High. Have you ever played outside all day and noticed that the length and locations of your shadow change as the hours went by? The sun's change and location cause a different the size, shape, and directions of your shadow. This is similar to how a tool known as a sundial works. Let's learn about the sundial history. The sundial is a device that measures time by the position of the sun. The sundial dates back as far as Egyptian and Babylonian times, around 1500 BC. The ancient Greeks then made sundials their own. They are the ones that developed the science of sundial. The Romans then adopted the Greek sundials. The first non-Roman sundial is from 293 BC. A sundial also used by the prominent civilization through ancient history to tell time. How sundials work? In most designs, a sundial consists of two points, the gnomon and the dial. The gnomon, usually a triangular shape, is placed in the middle of the dial, facing as close to true north as possible for best accuracy. All dials are constructed differently based on what latitude you are located. This is done by adjusting how close or far the timelines are upon the dial. As the sun rises, it will cast a shadow across the gnomon and project it upon the dial. The point of this shadow on the dial best describes the time of the day.
To create a sundial, we will need a paper plate, a marker, a scissor, a ruler, a protractor, a straw, and a hot glue gun. First of all, using the back of a paper plate as a dial, mark the center of a paper plate and draw a line and label it as 12 o'clock. Next, I will use a straw as a gnomon and make sure to cut the straw according to the stability of the plate. Make sure to poke the middle of the plate all the way through using a sharp jack so the straw can go through just fine. I will use a hot glue gun to strengthen the straw. Then my sundial is done. To set up my sundial, I will find a place with as much exposure to the sun as possible. Today is 8 November and the time currently shows 8 o'clock in the morning. I just need to follow the shadow that the sun is creating. I set my timer for 1 hour and come back at 9 o'clock. I just follow the line. The shadow moved a little bit because the sun is coming across the sky. I draw a line at 10 o'clock and I set my timer again. As you can see, the shadow looks so short at 11 o'clock because the sun is very much up overhead and it's creating a very small shadow on the dial. For an hour later, I'm going to take the reading at 12 o'clock, but the cloud suddenly became cloudy, so I took the reading at 12 quarters. Look how short the shadow is. For the next hour, I draw a line at 1 o'clock and set the timer again for 1 hour. The shadow is at 2 o'clock. An hour went by. I draw a line at 3 o'clock as the shadow gets longer. I set a timer for the last 1 hour. I draw the last line at 4 o'clock as it shows the last reading of my sundial. The weather in Sabah, Malaysia is very erratic. I live in Buluran district and the weather is cloudy numerous times. Luckily, I managed to get the data. However, there was an accident that happened where I did not manage to get the full reading like 3 weeks ago because my sundial was damaged due to being crushed by a car. I managed to take 7 readings instead. I will use a protractor to measure the angle of the shadow. The following is the data I obtained on 8th November and 1st December. Based on this graph, the blue line represents data on 8th November, while the orange line represents data on 1st December. Based on this result, I can conclude that as time goes by, the length of the shadow is getting shorter. The tilt of the Earth axis affects the length of our shadows. The Earth continues to spin until we are in the shadow. Our place on Earth is dark because the sun's light is blocked by the magnitude of our planet. Science Learning Hub 2019.